Hello everyone, I am Cecilia Panigutti and I am a researcher at the Joint Research Center of the European Commission in Istra, Italy. And today I will present the paper The Role of Explainable AI in the AI Act. This paper is the result of the efforts of an interdisciplinary team of computer scientists like myself and legal and policy officers of the European Commission. In the past years, there has been a growing concern over the opacity of certain widely adopted artificial intelligence systems. This concern has become a central theme in the development of digital policies and regulation worldwide. The need for transparency and explainability in AI has prompted intense discussions on the actual technical implication of these policies and regulations. In 2021, the European Commission introduced the AI Act, a proposal for regulating AI systems in the European Union. The AI Act adopts a risk-based approach. AI systems are categorized based on their risk level, considering their context of use and potential impact on health, safety, and fundamental rights. Notably, high-risk AI systems are subject to specific requirements, including transparency and human oversight. In this paper, we discuss the AI Act's intent and expectations regarding transparency and human oversight for high-risk AI systems and the role of explainable AI tools in this context. Is it true that the AI Act will ban black box AI systems from Europe? Is the use of explainable AI tools required by the AI Act? But first, a few considerations on terminology. Our paper delves into the realm of explainable AI and the concept of black box AI models and systems. When we say black box AI models, we refer to technically complex models that are difficult for humans to understand. The opposite of that are transparent by design AI models. Explainable AI aims to develop techniques to make the decision-making process of black box AI models more comprehensible to humans. The AI Act addresses the opacity of certain AI systems, notably those classified as high risk, for a focus on transparency and human oversight. The transparency requirement is in Article 13, and it states that high-risk AI systems should be designed and developed in a way that ensures that their operation is transparent enough for users to interpret and use the system's output appropriately. While some interpret this as a demand for transparent by design models, Article 14 specifies that the system should be accompanied by instruction for use, providing concise, complete, correct, and clear information that is relevant, accessible, and understandable. In other words, the AI Act aims to achieve transparency through the provision of relevant documentation and user information rather than by enforcing transparent by design models or a mandatory use of explainable AI tools. Article 14 of the AI Act establishes the human oversight requirements for high-risk AI systems, aiming to enable effective supervision by natural persons during system use to prevent and minimize residual risks. Among other, Article 14 also emphasizes the importance of user interpretation of AI output and outlines measures such as designing suitable human-AI interfaces, ensuring system responsiveness to human operators, and assigning competent, trained, and authorized individuals to fulfill this role. In addition, according to the AI Act, the trustworthiness of AI systems goes beyond the transparency and human oversight requirements per se. Providers should assess the combined effective interaction of all of the AI Act requirements, taking into consideration the state of the art. Article 9 on risk management explicitly recognizes this need. Thus, the earlier discussed transparency and human oversight requirements should be implemented in alignment with the risk management system. While the AI Act does not specify the use of any particular technical tool, it does not restrict the use of explainable AI either. Actually, further research in this field is advisable. In this paper, we have identified some limitations of current explainable AI research that needs to be tackled to effectively address challenges related to AI opacity. we have identified three key limitations. First, AI explanation can be unreliable and not robust, making them vulnerable to adversarial perturbations and manipulation. Second, explanation evaluation is complicated by the lack of standardized metrics and by the lack of a ground truth. Finally, the relationship between AI explanation and trust is underexplored. Some studies even suggesting that such explanations might increase automation bias. Moving beyond explainable AI, we can demonstrate that transparency and human oversight measures are not exclusively dependent on explainable AI tools. We will now provide some examples of such measures for an AI-based proctoring system that do not rely on explainable AI or transparent by design models. So, AI-based student proctoring systems are used to monitor and detect suspicious behavior during tests. In our mock-up use case, the system employs a black box algorithm that performs facial behavior analysis, shown on the screen right now. This algorithm can infer high-level information such as facial microexpression, gaze direction, head pose. We will now showcase an illustrative and non-exhaustive sample of measures that providers can identify and implement to address the transparency and human oversight requirements of the AI Act without necessarily using interpretable AI or explainable AI technique. First of all, the provider of the AI system ensures clarity by explicitly stating the intended purpose of the system, which is to detect suspicious behavior during tests. The system is also accompanied by relevant documentation and instructions for use. As the designated overseer of the system, the teacher receives specific training on its typical failure modes, especially false positive, that could harm students' reputation and career. The system interface visually represents the extracted facial information. It objectively analyzes facial behavior using facial landmarks, head pose, and gaze direction. Rather than using binary yes or no labels for detective cheating, the system quantifies facial behavior through action unit and intensity values. This approach encourages active engagement from the teacher, preventing automation bias. The AI proctoring system provides an intuitive and controllable interface. It displays all systems output, including confidence values, enabling the teacher to make informed decisions based on visualized data. If cheating is detected, multiple individuals can inspect the alerts and the corresponding frames. Also, the affected student has the opportunity to communicate with the teacher during or after the test to explain their behavior. In summary, the presented system integrates various measures to address transparency and human oversight requirements effectively. These measures include comprehensive documentation of system use, training for teachers to handle false positives, an interactive interface for active engagement, involving multiple individuals for inspection, and enabling controllability and intervenability. In conclusion, the AI Act tackles opacity with an holistic approach by considering trustworthiness as a result of interconnected attributes within AI systems. It provides flexibility in dealing with AI opacity, allowing providers and users to design compliance measures without mandating specific technical tools. And importantly, the AI Act does not impose a ban on black box AI systems.